Hi dear student, this is Sanal from Hilbodhi classes. Welcome back to AS Level CAIE 9702 series, Module 1, Part 8. In the last session, we have discussed about principle of homogeneity and we have done 3 questions from that. I hope you have done the practice. In this video, we are going to discuss about vectors. So vectors are the quantities with the direction and the magnitude. Direction and magnitude means some quantities you need to specify the direction for complete meaning. For example, for a one-way door, I'm asking you to, you applied 5 Newton to open that door. Okay? If it is a one-way door, I need to specify the direction from outside or inside. Right? Otherwise, it is meaningless. So similar quantities with the direction and magnitude, that is called a vector. Vectors are quantities with magnitude and direction. Magnitude and direction. Both magnitude and direction should be there. Scalars, what are scalars? Scalar quantities means quantities with the magnitude only. Direction is not significant in this. Quantities with the magnitude only. Certain basic important things you need to understand about vectors. You can represent a vector in your paper with an arrow. This represents a vector. And you understand the arrow, no, the head. This is called a head. Head of the vector, this is tail. Tail of the vector. The length of the vector will represent its magnitude. The length, when you check, this is length will represent its magnitude. And this arrow will represent its direction. Okay. So when you consider a vector, okay, length means 10 centimeter means there will be a scale. 1 centimeter to represent 1 Newton means 10 centimeter means 10 Newton. Okay. So you can shift this vector. It is called parallel shifting of vector. Any part of this paper without changing the angle. It has a direction. Look at that. Along x-axis, it has a direction. If you don't change this angle, you can shift it. You can draw it any part without changing the angle, without changing the length. This vector won't change. Okay. If you want to add two vectors, make sure that you are adding a vector and joining head to tail. Okay, this is graphical method. When you add two vectors, you make sure that the head of one vector is joined to the tail of other vector. Okay, then the third side, when you join the tail of the first vector to the head of the last vector, that will be the resultant of these two vectors. That means sum of these two vectors. So what is the sum of this vector? Resultant of this vector a plus b. This one will be a plus b. So graphically, if you want to add two vectors, make sure that first one, it should be joined head to tail. Head to tail joining should be there. And the third side, you join the tail of the first vector to the head of the last vector, you will get the resultant of this vector. It need not to be only two vectors. Okay, for example, one vector is here, one vector is here, C, and this is another vector. Okay, this is A, this is B, this is C, this is D. So what is the resultant when you add all these vector? What is the resultant of this vector? This resultant of this vector will be, you join the first vector tail, then to head of the last vector, and this is what? A plus B plus C plus D. Understood? This is vector addition. You can move now. You can apply this shifting, parallel shifting here. For example, some vectors are given like this. This is A vector, this is B vector. So how will you add? Don't draw that like this, okay, and close it. It is not correct. Because For addition, what I told you, you need to remember this statement. The vector should be head to tail join. This is where you make the mistake. Okay, what you will do, you can parallelly shift vector. Look at this one. This vector you can parallelly shift to this point without changing the angle. Okay, that is the key. So you can join the tail and head here, and this will be B. Now you can add this, right? You can join this tail of the first vector to the head, and this will be your A plus B. You need to remember this one. Okay, this point, head to tail join, and then tail of the first vector to the head of the last vector. That will be the resultant. That will be the sum of vectors. Understood? Parallel shifting, you can use it for that. If you are, one more point, this is the first point you need to remember for addition. Angle between vectors. Angle between vectors. If you have one vector like this and another vector like this, and if you consider this angle, this is not the angle between the vector. Angle between the vector, you need to take one thing, either tail to tail join, AB. Then you can take this one. This is the angle between the vector. Or it should be joined head to head. Both are correct. The angle between vectors, how will you calculate? The angle between vector, if you want to know angle between the vector, make sure that it's either tail to tail join or head to head join. Okay, so you need to remember this also. Till now, what we have learned, a vector can be represented with its length as magnitude and a head arrow as the direction. If you want to add two vectors, what you will do, you will join head to tail, then you will join the tail of the first vector to the head of the last vector. You will get the resultant, that is A plus B. Remember this point, this is very important. Okay, on your question, you may not check this direction, that is the key. Okay, you may make mistake here. For addition, you are adding head to tail of the vectors. Clear? Then if you want to find out the angle between two vectors, make sure that either it should be joined tail to tail or head to head. Clear? Then next, resolution of vectors. Resolution of vectors. If a vector is given, look at this. A vector is given in the paper. Look at this. You know that this is at an angle with the x-axis. Okay, your analysis will be between x-axis and y-axis. Okay. For calculation, you can resolve this. This is at an angle, say theta, with the x-axis. For analysis, you will consider along x-axis and y-axis. You can resolve this component. Say this is a velocity vector or force vector, any vector you can consider. It has a component along x-axis. You can resolve this along x-axis and the y-axis. Got it? The component along x-axis, when you check, okay, how can you resolve it? One component along x-axis, one component along y-axis. Okay, one component along y-axis. For that, you know that this is V, right? This is the angle. If you want the x-axis component, you need to consider this triangle. Okay, with that angle, including this angle theta, consider a triangle. If x-axis means what is that? Adjacent side, right? This is adjacent side of the triangle, right? If adjacent side is your requirement, then it will be cos component. So it will be V cos theta will come along this axis. Look at this vertical component. Vertical component is equivalent to the opposite side of that triangle, right? So if vertical component is required, then it will be V sine theta component. Understood? Why it is? You know that sine theta is what? Sine theta is equal to opposite side by hypotenuse, and cos theta is equal to adjacent side by hypotenuse. Look at this one. You require adjacent side here for x axis, right? X axis component. So adjacent side means you cross multiply with hypotenuse multiplied by cos theta. What is the hypotenuse? V cos theta, right? If you require opposite side, look at that. Perpendicular component is equivalent to the opposite side of the triangle. So opposite side you require means what? Cross multiply this one. Sin theta into hypotenuse. What is hypotenuse? Is V. So V cos theta. Don't memorize like always horizontal direction is cos theta component, vertical direction is sin theta component. Okay, it need not to be like that. It depends on the theta you are considering, the angle you are considering. For example, the same thing, the same velocity, when you check same velocity v, the angle given is now theta. Here this angle is given. Okay, inclined to plane question, if you know this concept only you will make correct resolution. Okay, resolution of vector. So you check this one, this is x-axis, y-axis. So this is the angle, means you will consider, including that angle, you consider the triangle. Okay, so now you check this side, vertical component you require. What side of this triangle? This is the adjacent side. So it will be v cos theta will come here. Here, when you check this one, x-axis is the opposite side of the triangle, right? So here it will be v sin theta. So don't memorize like the always horizontal direction, it is cos theta component. Okay, it depends on the theta. You need to analyze the question, resolve it properly. Understood? If you understand this concept, no, you can apply this in vectors. We will apply in a lot of places later, especially in mechanics and dynamics. So that will be module 2 and 3 of this course. So you need to understand this concept properly. We will apply this. When we apply this in the questions, I will explain there one more time, but you need to understand this resolution of vector is a very important topic. Okay. So with this, the theory part of module 1 is finished. Now, one more video I will do for the practice, 3 structured question, 5 MCQs. Okay. From your past paper. That means the past paper, topical past paper practice. One more session will be there in this module. After that, we will start the third module, which is kinematics. So see you in the next video with the topical past paper questions. And this is Sanal from Heal Bodhi Classes. Bye.